Hello friends, we are discussing about the feature scaling, and today we will discuss about one of the method of feature scaling which actually scale the data on each observation, not on each feature. So you may guess it. So this is the normalizer transformation which is present in the scikit-learn pre-processing library, and we will discuss it in detail. So first question is, why do you need feature scaling? We have discussed it in detail in our previous video. You can watch it. Today we can recap it. Like some of your machine learning algorithm, for example, the linear regression or the logistic regression or the k-nearest neighbor or the neural network. So these kind of machine learning algorithm expect your data in the uniform or almost uniform variance so that their objective function can be estimated properly. If there is a higher magnitude of variance in some feature and in the lower magnitude of variance, that means not uniform variance between the feature, that may impact the objective function and the accuracy of the estimation. So to mitigate that, we introduced feature scaling. So that is a very important step in the machine learning algorithm. So we have already discussed some of the transformation method which is present in the scikit-learn pre-processing library as the feature scaling method. To name, we have already discussed about standard scaling, we have already discussed about min-max scaling, robust scaling and the max-ab scaling. Today we will discuss about the normalizer method. So as we have already told that it is a observation or the row level transformation, not the feature level or the column level transformation. And the main agenda of doing it is like to find a uniform variance for all the feature. Let's discuss how it will do the things. So there are three methods of using the normalizer method at the row level. The first is L1 norm, where the Manhattan distance is used. So in this example you can see, like for the row 1 there are four values of four features, right? 4, 1, 2, 2. So it's irrelevant which features has which value. So it will like sum it up to find the Manhattan distance. So in the first row it will be like 9. So it will divide each of the value by the sum and get the normalization, where it will produce the unit norm. That means if you add all the normalized feature value, it will introduce to 1 or it will summed up to 1. So it's a unit norm. So in the L2 norm, you can see this is defined by the Euclidean distance. So you need to take square of each value and then sum it up and then square root it. And then you divide that value for all the value in that row. So let's discuss it with the row 2. So 1 square plus 3 square plus 9 square plus 3 square will be 100. So square root of 100 is equal to 10. So this will be 1 by 10, 3 by 10, 9 by 10 and 3 by 10. The last option is the max norm, or you can say it's also infinity norm. In this normalization method, the maximum value, absolute value actually, is used to divide all the features to get it normalized. So let it explain by the row 3. So we have 5, 7, 5 and 1. So in this case you have like 7 as the maximum absolute value and then we can divide 5 by 7, 7 by 7, again 5 by 7 and 1 by 7. So we are clear what the normalizer transformation is doing on the data. Let's see with an example. First thing, I will import the normalizer from sklearn.preprocessing import normalizer, and then I define the normalizer. I am not passing any parameter. Let's see what is its default. I have already explained it should be L2 norm. So norm dot get params. Yeah. Now let's define one data set. So this is the data set we have already shown here, and let's fit and transform the normalizer to the data. And this is its value, and it's tallying for the L2 norm. Let's change the norm to L1 and it will change eventually. So it will be 4 by 9. For the second row, it will be 1 by 16 and 3 by 16 and 9 by 16 and 3 by 16. For the last row, it will be 5 by 18. So it's calculating, it's in the decimal form, it's calculating in that way. And you can change this norm to max. You see the norm is now max, and now fit and transform the data. So you see, for the, this is the highest value in the first row, so it will be 4 by 4 1. So 9 will be the highest value in the second row, so 9 by 9 will be 1, and 7 will be the highest value in the last row, so it will be 7 by 7 is equal to 1. So that is how the three kind of norm is working. But please remember, this normalization is at the observation level or the row level, and it's not at the feature level. So that's why it is extremely rare to use it in some use cases. My question to you is like, have you find any use case where you have used the normalizer method, not the other feature scaling method? Let's continue in this tutorial series. Thank you so much for watching this video. Please stay tuned for more videos like this, and leave a like and subscribe for more videos. Thank you.